Good morning, students. I, Dr. Binita Verma, Department of Science and Technology, JVWU University, Jaipur. So, our today's topic is digital computer. First of all, we discuss what is digital computer. Digital computer can be considered as a digital system that perform various computation tasks. Okay. The first electronic digital computer was developed in 1940s and was used primarily for numerical computations. The digital computers use the binary number system, which has two digits, 0 and 1. A binary digit is called a bit. A computer system is subdivided into two functional entities, hardware and software. As we that, the hardware consists of all electronic components and electromechanical devices that comprise the physical entity of the device. The software of the computer consists of instructions and data that the computer manipulates to perform various processing tasks. So, आप पहले भी पढ़ चुके होंगे ब्लॉक डायग्राम ऑफ डिजिटल कंप्यूटर. Okay, so I remind you in block diagram of computer system, which one is first one is RAM, random access memory, CPU, central processing unit, input output processor. In input output processor there is input device and output device, और सबके अपने अपने वर्क होते हैं. Then that means CPU contain arithmetic logical unit for manipulating data, a number of registers for storing data, and control circuits for fetching and executing instructions. Okay. Then memory unit of a digital computer contain storage for instructions of data. Then RAM, random access memory for real time processing of the data. Okay. Then we all know about input output devices. Input output device for generating inputs from the user and display output for final result to the user. Then input output devices also connected to the computer include the keyboard, mouse, terminals, magnetic disk, and other communicating devices. So let us discuss about logic gates. What is logic gates and what is the function of logic gates? Logic gates are main structural part of digital system. Logic gates are the block of hardware that produces signals of binary in the form of 1 and 0 when input logic requirements are satisfied. Each gate has a distinct graphic symbol and its operations can be described by means of algebraic expression. The 7 basic logic gates include AND, OR, NOT, XOR, NAND, XNOR. Okay. Then the relationship between the input and output binary variables for each gate can be represented in tabular form by a truth table. Okay. Truth table. Each gate has one or two binary input variables designated by A and B, and one binary output variable designated as X. Okay. So let me discuss about first one, AND gate, A and D, AND gate. So the AND gate is an electronic circuit which gives a high output only if all the input are high. The AND operation is represented by dot sign. Okay, just and the graphical representatives is just like B. Okay, when we take when we make a truth table of AND gate, so if we take A is 0 and B is 0, then what we have the output, we get the output is 0. Okay, then when A is 0 and B is 1, then 0 dot 1, what we get the output is 0 again. When we take 1 and for A 1 and B for 0, then the output becomes 0. And when we take 1 1 in both A and B, the output becomes 1. 1 dot 1 equals to 1. Okay, so I hope you clear what I say. It gives high output only if all the input are high. Means when we take the value of A is 1 and value of B, the output becomes also 1. Okay, the output is also high. Then the algebraic expression of AND gate is x is equal to A dot B. I hope you understood. Okay, then so our next topic is OR gate. OR gate is an electronic device which gives a high output if one or more of its input are high. The operation performed by OR gate is represented by plus sign. Okay, and algebraic function of OR gate is x is equal to A plus B. So now we make truth table for OR gate. If we take A as 0 and B as 0, and we get the output 0. 0 plus 0 equals to 0. Okay, and if we take A as 0 and B as 1, so we get the output as 1. 0 plus 1 equals to 1. And if we get A is 1 and B is 0, and we get the output as 1. 1 plus 0 equals to 1. And if we take A equals to 1 and B equals to 1, then the output becomes also 1. Okay, so I hope you understood. 0 0 output becomes 0, 0 1 output become 1, 1 0 output become 1, and when we take 1 1 output become 1. So what's its definition? It gives a high output if one or more of its input are high. Okay. Then next one is NOT gate. Okay. NOT gate is just an inverter. Okay. Means when we take 1 as input, we get output 0. And when we take 0 as input, we take output as 1. Okay. So the definition of NOT gate is an electronic circuit which produces an inverter version of the input as its output. It is also known as inverter. Okay. Now next logic gate is NAND gate. AND and D. NAND gate. Okay. NAND gate means not AND. Not AND. Okay. We already हम पहले भी पढ़ चुके हैं. We already discussed about AND gate. Okay, so now we discuss about NAND gate, not AND gate. Okay, so not AND gate is very simple. It is inverter of AND gate. Okay? So not AND gate or NAND gate, which is equal to the AND gate, followed by NOT gate. Okay? The NAND gate gives a high output if any of the input are low. The NAND gate is represented by a AND gate with a small circle on the output. The small circle represents inversion. Okay? So the algebraic function of NAND gate is x is equal to a dot b dash. Okay? A dot b whole bracket then dash. Okay? And the truth table of NAND gate is when we take a equals to 0 and b equals to 0, we get the output as 1. Okay? 0 dot 0 equals to 0. This is AND gate and this is inverter of AND gate. So 0 dot 0 is equal to 0 and inverter of 0 is 1. Okay? Just like this, when we take a equals to 0 and b equals to 1. So 0 dot 1 equals to 0 again, and the inverter of 0 is 1. Okay? Then when we take a equals to 1 and b equals to 0, and 1 dot 0 equals to 0 and the inverter of 0 is 1. And finally when we take both as 1 1, means a equals to 1 and b equals to 1. So 1 dot 1 equals to 1, but we take inverter. So inverter of 1 is 0. Okay? So finally 0 dot 0, then x equals to 1, 0 dot 1, then x is equal to 1, 1 dot 0, x becomes 1, and 1 dot 1, x becomes 0. Okay? I hope you understood. Now next one is NOR gate. NOR gate is similar to AND gate. This is NOT OR gate. Okay? NOT OR gate means this is inverter of OR gate, just like AND gate. Okay? So what is in this? So in the NOR gate, which is equal to OR gate followed by NOT. Okay? The NOR gate gives a low output if any of the input are high. The NOR gate is represented by OR gate with a small circle on the output. Okay? The small circle represents inversion. Okay? The algebraic expression of NOR gate is x equals to a plus b or whole bracket. Okay? And truth table. The truth table of NOR gate is very simple. It is just like inverter of OR gates. Okay? So when we take 0 0, the output become 1. 0 dot 0 plus 0 0, and the inverter of 0 is 1, and 0, when we take 0 and 1, the output becomes 0. When we take 1 and 0, the output becomes 0. When we take 1 and 1, the output becomes 0. Okay? So here we get 1 only when we take both a 0 and b 0. We get the output as 1. Okay? I hope clear to you. And now we discuss other logic gates in next classes. Okay? And if you have any doubt, any problem, then talk to me. Thank you so much.